It's a real privilege to have you join us and to have this really great panel with us today. Just as a little bit of context, we got so many questions, and the webinar on the 27th of September was so well received that it really was a very organic next step to have one that was simply dedicated to engagement with all of you from around the world and having your questions answered. So we're excited about this. Let me quickly introduce our panel. Joining us today is Jan Koller, Group Manager from the Fraunhofer Institute for Manufacturing, Engineering and Automation. Welcome, Jan. Gregor Ohnemüller, Chair, Manufacturing and Remanufacturing Technology of the University of Bayreuth. Welcome, Gregor. And Mike Hague-Morgan, co-owner and majority shareholder of Autocraft Solutions Group. Welcome, Mike. So we're gonna spend just a few minutes with Jan and Gregor to help us orient around the big picture view of what the electric vehicle and remanufacturing nexus looks like for a few minutes here, and then we'll jump straight into Q&A. We already have a list of questions that were sent by you as part of the registration, but we absolutely look forward to having you type your questions in as we progress through the next hour. So welcome again, and Jan, over to you.
Yes, thank you, Rajiv, for the introduction. So I will start the webinar with some input on the current challenges if we come to remanufacturing battery systems. And therefore, we categorized the topics in the ecosystem of battery remanufacturing with three key topics. So one is the logistics, getting the battery systems from the workshops to a remanufacturing facility, about the infrastructure which is needed for remanufacture, but also for the workshops, and the technology and processes behind remanufacturing those battery systems. And of course, there are also some legal requirements when it comes to this topic. So let me start with the transportation of the battery systems. So at the moment, there are no regulations on the public law about the storage of the lithium batteries. And if you transport the battery systems within the vehicle, so if they are built in the vehicle, it's not a problem to transport it. But if you transport the battery systems alone, so disassembled from the vehicle, then they are can be classified as hazardous substances. And there are some special regulations about the packaging, and also if it comes to the storage and the transport. So most of the times the battery systems are disassembled to module level to have a lower energy level if you transport them. And that's still a topic, how to transport them safely. It's also about the infrastructure, which you can see here, because in many activities, batteries can catch fire, and the emerging fires, unlike other fires, cannot be simply extinguished. So that's, of course, a threat, always if you work with this high voltage battery systems. And therefore, specific training is also needed for the workers which are handling the battery systems, and also the workers within the plant, but also, for example, for the whole logistics and the whole supply chain to see what you can do in case of a fire. And of course, you also need special protective equipment if you handle those battery systems. And fire and work safety is still in development. So if you look in the news, sometimes you read about like burning cars on the street and the hard to extinguish fires. And that's also one big risk, having those battery systems within a facility, so that there could be batteries catching fires or simply battery cells, which lead then to a fire of the whole battery system. And then I will hand over to Gregor to talk a bit about the technology involved with the battery remanufacturing.
Thank you, Jan. Yeah, I will take over from now on, since on the right side, the left hands or arms are mine, and I'm in charge of the disassembly investigation at the University of Bayreuth. And yeah, we had made several points there. For example, one danger of the batteries is that if you want to reuse or repurpose them, you can't discharge these batteries. So short circuits and the high voltage are always a danger. Also, the high voltages or the voltages make the disassembly pretty complex, because you can always short circuit with metal tools. And we have up to 800 volts at the moment, and these are life-threatening. And the next point, the disassembly investigation showed us that the joining techniques from the module level down to the cell are often welded or casted and glued, so you can't disassembly in a non-destructive manner. And in the last part, the current legislation favors are more in the favor of material recycling, and product recycling isn't shown at the moment. And regarding to the material recycling, on the next foil, we have the waste hierarchy. At the lowest point is the material recycling, and we want to use the chances to preserve the value of the batteries and get in higher circular economy options like reuse, remanufacture, or the repair. And at the moment, these options aren't possible for the best battery systems that are on the market. And we try to fix that with several projects like the redesign or our disassembly investigations. Yeah. Thank you very much. And yeah, I can lead over to Rajiv again.
Perfect. No, thank you, Gregor, and thank you, Jan, for framing the conversation for us. Broadly speaking, we're looking at remanufacturing, as I'm sure many who are joining us today are aware. As the International Resource Panel calls it, is a value retention process. In other words, you're by designing products and designing ecosystems in a way where you can get products to provide the utility you're looking for over multiple life cycles. There's some real value, not just in the use phase, but looking at it broadly from the life cycle perspective. And I think a lot of the questions that we've seen coming in the past, as well as for this webinar, are around the ecosystem as well as the technology. So Mike, maybe I could invite you, and you're in the middle of this evolution that's occurring from the standpoint of providing solutions so that batteries can be remanufactured in a sensible way, and coming up with some creative ideas from the standpoint of your mobile system versus the stationary system. Could you talk a little bit more about what's kind of generally happening in the space of batteries, and also dovetailing what your product and company are doing? And then I'd like to eventually zoom out to look at the EV ecosystem broadly, and not just the batteries. So
thank you, Rajiv. Yeah, for us, we wanted to be an EV because we were traditional engine remanufacturer, and there was always going to be an end of life of that. So we were kind of forced to go into it, almost unwilling to a point, but very quickly we realized what an exciting opportunity it was for us, and how remanufacturable batteries could be, which isn't what we thought at the start. But it takes you a while to really learn and understand this new technology in this new market before you can get your eyes open to what a great opportunity it is. But as with all new technologies, what you think you're going to have and what you actually have in reality will be different. And the question is how different, I think. Everything was designed not to fail, just as engines are not designed not to fail, but there's always And new technology means that some of the failure rates that we're seeing and the failure modes are, they're not, you can't generalize them at the moment. You've got batteries which have been very, very reliable, but other batteries, slightly different application or slightly different configuration, proving to be much more unreliable than they ever thought they would be. With that, along with the general world we're in now, and this is a much faster introduction of EV that many thought of, because it really is a fast transition that we're going through. Means it's a very dynamic market from week to week, month to month. The market landscape is changing in terms of where the main issues are, what type of packs, the volume, the location. So we're having to be really flexible in what we do as a business. We can no longer sit here at our traditional UK base and expect things to come to us. We're now able to go out, and that's what the mobile element that I showed at the last webinar, that ability to go out to a facility, either with what we call a triage trailer or a full factory, expandable factory on the back of a HGV, that is so important to actually meet these unpredictable demands.
Yep. No, thank you. Yeah, that's with the rate of change, I think you're seeing that information flow going back to the value chain also quite rapidly. And I think that's pushing not just automakers at large, but also battery manufacturers to kind of rethink their design on a more fundamental level. And Jan and Gregor, you've been doing some work in this area from a research perspective. You mentioned some of the issues are around the challenges that come with essentially disassembly without destroying some or part of the battery. What are you seeing, in general, from the standpoint of, of the batteries that are out there? What percentage of them, for example, are fundamentally designed in a way so that remanufacturing is easier? And are you seeing the battery manufacturers moving towards design that allows for ease of disassembly and that kind of thing?
I think the remanufacturing or recycling aspect of batteries just now comes back to the mind of the manufacturers, and they had to overcome some obstacles first, like EVs in the first point being bought on the market or getting accepted. And so they work more in the direction of energy density and the fear of not coming far enough with the battery systems in comparison to a combustion engine car. And so recycling and remanufacturing just now comes back into the mind, and the EVs on the market right now are more optimized in cases of also fire retardant and energy density, or just miles you can drive.
Yeah, this is also my understanding, that the lithium-ion battery systems which are now on the market are specifically optimized regarding the performance of the battery system and also with the costs to produce them. And the more and more batteries are on the market, now also the customers with a battery system that failed are looking for alternatives to just buy a new battery system, because they are quite expensive if you need one without the warranty, or after the warranty phase ended. And so now the manufacturers, the OEMs, look into other options, like, for example, remanufacturing or repair of the battery systems. And I think also the scarcity of materials and the consideration of a price increase of those materials leads to think about those circular economy options.
Yeah, no, you mentioned cost, Jan, and then Mike, I remember in the previous webinar you'd also mentioned that in terms of the cost for replacing versus the cost for replacing a battery versus just buying a whole new car is just such a big piece of the cost. One of the questions that actually we had unanswered at that point was, and this might be dependent on the product, but determining the state of health, right? Like, at what point do you engage in remanufacturing, trying to balance all those pieces, right? The environmental impact, the cost to do it effectively, as well as the efficiencies that you're trying to get. And I'm guessing there's no silver bullet answer there, but how are companies, or how are you seeing that space kind of evolve in terms of, where do you make that judgment call on remanufacturing and bringing it back so that you're maximizing in both the efficiency as well as minimizing cost and environmental impact? Or is there even such a sweet spot?
There is a sweet spot in terms of, it's a BEV. If you've got a BEV, you've got a pack of 15, 20,000 euros of value, then you've got a lot of value to go at, and you can do a lot for that money and still give the customer a cheaper option. Whereas some of if you go to the other end of the scale and you've got these mild hybrid, a kilowatt or half a kilowatt, there's not a lot there to really of value versus a new one. So the more kilowatts, the more money, the better chance you've got of having a remanufacturing business case that works.
Okay. Any thoughts to add, Jan and Gregor?
Yeah, I think there are various factors which influence, of course, the costs of the remanufacturing process, but also you have to look at the demand and the various battery systems which are on the market. So I think that's also something to keep in mind, to see what is the market for those also remanufactured models. You also need someone to buy them. And then it's also about the disassembly depth. So do you disassemble them to module level, to cell level, which also has different cost aspects. And I think at the moment we are mostly talking about disassembling the battery systems on the module level, to exchange modules to bring them back to a useful life.
Yeah, to back this up, if you look at, for example, batteries for e-bikes, you also have very low numbers of energy, but a cell replacement would be very beneficial, because an e-bike battery costs like about 1.2 thousand euro, and the replacement of all battery cells would cost like 400 euros. So the replacement of individual cells, like 10% or so, would be very beneficial in this kind of business model.
Yeah, but the issue we find on e-bikes as well as some cars is you can't actually get down to a cell level. You're having to do it at module level. So e-bikes is something that our technology entirely works for, but the e-bike packs that we've taken apart, they are there's nothing left of them. You have to replace all of the cells, and by the time you've done that, you're into a cost whereby a new pack is the only option. It's it's a real pity, because it's probably only one cell in that entire pack that you need to replace. It's terribly wasteful. It's the single-use world that we've, as a society, of all too much promoted, but now, as remanufacturers, I think our time is going to come, because the world's resources are getting more and more scarce, costs are increasing, and we can really offer a more competitive, environmentally friendly way of doing things. And that's why the circular economy is growing as fast as it currently is. So just another great example of why we are so important to the world, and why we all need to educate the world of what we can do to make it a better place.
Yeah, no, well put, Mike. Thank you. I want to quickly, there's a couple of questions that are coming in here. And Jan, you mentioned this a little bit, or you touched on it a little bit in your opening remarks around the issue of fires and safety. And there's a couple of questions here, and I'm going to sort of try to blend the narrative. One of them is specifically asking about the reliability of electric vehicles compared to internal combustion engines and hybrids. And the questioner, I think it's a kind of broad kind of question from a reliability perspective. So I'll leave that more open for you to answer on however you see fit. But then also the question about the issue of fires caused by batteries, and as far as my understanding goes, but please feel free to correct me, that it's statistically quite low in the totality of it, but when they do occur, they can be quite dangerous. So maybe starting with reliability and then talking about the safety issues associated with batteries. Whoever wants to take it.
Well, Rajiv, you set me some homework, didn't you, on the pre-call last week? So let me see if I can share something I've got off the internet, which is a huge data set from Tesla's. Let me. Can you see that? Good. Okay. So when we talk about mileage, really what you need to look at is cycle numbers. So a battery will degrade over time due to a number of factors. It'll be faster or slower due to temperature and charge cycles in terms of how aggressively you put energy in and out of it. But fundamentally, they will always have a certain amount of degradation with time and cycles being the biggest single factor. So what you've got here is a data set of thousands and thousands of Tesla vehicles, and you can see that this dark blue here, which hopefully you can see my cursor, that is where the majority of packs are. And over time, you'll see that actually they're not the number of cycles, so that could be every time you were to charge it. So if you were to charge it every single day, fully charge and discharge, heavy user of the car, which is not actually what people do, it might be once a week, then about here, just after between 300 and 400 cycles after a year, that's where you would be. And you should have only lost just a few percent. You get an initial drop when you initially charge it for the very first time, and that's before it even gets into a car. And then you'll get this gentle kind of degradation. So to be clear, batteries are by and large very reliable, and most of them you're never going to have a problem, and they will last the life of the vehicle. However, what you've clearly got here is one that's failed after 150 cycles, another one at 300, and then you start to get more and more. So where you see manufacturers pitching their warranty appears to be 600 cycles. So within the warranty period of all of that data set, there's not actually that many, in this case Teslas, that have failed within 600 cycles. It might be that the manufacturer sets it 1,000 cycles, 2,000 cycles. I'm just talking general principles here. But you will see, therefore, that other than what clearly are manufacturing faults, which you get in the early part, then chances are you're going to get out of a warranty period before you have a problem. But then out of the warranty period for remanufacturers, that's where your big market is going to be. And this is why some companies are not actually investing in remanufacturing batteries now, because the investment is quite high, relatively small failure rates, unless you've got a design problem, and some manufacturers have got some issues. Okay, don't scare people that there's not a massive problem out there. There are some specific issues. But generally, it's when the vehicle gets to over 800, 1,000, 2,000 cycles in its life. That's when remanufacturing will really kick in a very big way. Did I answer the homework question, right?
Yeah. You did. No, that's great. Thank you, Mike. I was going to, just for clarity, by cycle you mean it's essentially a charging cycle, right? So
a full charge and discharge.
A full charge and discharge. Okay.
Yeah.
And so if the warranty is based on the number of cycles, so in terms of the time that goes by, that essentially is variable. It could be a few years to much longer, depending
if you're
on frequency.
If you're a high mileage user like me, you're going to be charging twice a week. Therefore, 600-700 cycles, couple of years, and there's a fair few there that have failed within that period. Realistically, most people are doing, most companies are going to 5 or 7 year warranties. So they must be looking at 2,000 or 3,000 charge cycles as what they believe it will be before they have a problem.
Got it. Perfect. No, thank you, Mike. And then the follow-up to that was this issue around fires and safety. And maybe Jan and Gregor, from the research that you're doing, could you shed a little bit more light on this particular concern?
Yeah, 2 points to this. On the one side, during disassembly, there's an actual danger of causing a fire because of short circuits or heating the cells during grinding or cutting or even drilling. And so you can cause a thermal runaway. And on the other side, the average fire danger. It's true that there are very low numbers of electric vehicles burning or even the battery burning. But at the moment, there are no good or efficient ways to extinguish the flames or the fire. And only investigations take part in this direction.
Right, but compared to the likelihood of that occurrence is in a very, very small, narrow band of circumstances, right? I just want to clarify. Right.
Yeah, it's much lower, and the most danger is from the plastics built in the car. But if the battery burns, it's a really big problem. But this is a very rare case.
Right.
I think it's very important for remanufacturers to be aware that when you actually are going to test, how you test is critical. So if you've got a pack which has clearly got an issue, and then you start testing it and you test it by putting lots of load in over a lot amount of time, then you are greatly increasing the chance of generating thermal runaway. So you have to monitor exactly what you're doing and be able to identify from the responses that you're getting back if you started to create thermal runaway. So how you test is really, really critical. In a vehicle, the batteries are pretty stable. You've got my understanding is when you initially make the cell and make the module, there's a risk there. But once it's actually gone through and gone through the end of line production and it's past that, they're pretty stable and the chances of you actually having a problem due to its normal uses are very, very rare. It's more likely to happen in a crash, or as I say, by testing it. Because if you've got a problem in there and you really load it up, and you load it up over a significant period, then you can get thermal runaway. And for a remanufacturer, that's vitally important that you don't do that.
And to also answer the question how to extinguish the fire, at the moment you can only use water or a small percentage of foam Wix pipe to lower the surface tension. That's the only ways to extinguish at the moment, because you can't use foam because it produces its own oxygen.
Yeah, and also the fire ignites again. So
we don't bother. If we get a fire, we've got a patented way of containing it with a box, and that box moves to a location and you let it burn 1, 2, 3 days until it's finished, and then you go and deal with it when it's safe to do so.
Yeah, the only way is containing at the moment.
But I just want to make a fine point on this distinction, because I don't want our audience to mistake that there is a fire issue, but that's in very, very, very specific circumstances, not or hardly ever during the use phase. And I think that's important to clarify, that batteries, when they're being used in vehicles or 2 or 3 wheelers, are in fact incredibly safe. And it's only in specific circumstances that there is a risk of fire. Yeah, very good. Thank you. Okay, so we got a few more questions coming in. I'm going to read this for everybody. Can you give us your opinion on the duration for reassembly compared to the non-destructive disassembly duration? And the question goes on to say, for example, if it takes 1 hour to disassemble a battery system, medium size to module level, we assume a reassembly time of X. And so what does that look like? Or is that variable depending on design, I'm guessing? Whoever wants to take it.
Two variable, depends on the design of the pack. Some are really easy. Some you can take many hours to get modules out, and particularly if you've got cooling systems, more active cooling on packs these days, because trying to get more performance out of the power density out of a pack. Some of the plates that they're then fixed onto are with special glues. Depends on the pack.
Right, that's fair. And in another question as a follow-up, how many cells in a module would need to be unusable for the module to not be remanufacturable, maybe as a percentage? So what's the lower limit where you go, this is not worth remanufacturing anymore? Or is that not how you're making the judgment call?
Typically, it's only one cell that's failed within a module, but because you can't break the module down, you have to replace the whole module. If you've got a problem in a module and one cell has been overloaded, it's failed, it then overloads the others. So you've really got to, it's like a cancer, and you've got to cut that out, and you've got to know where to cut it out. And the testing that we've developed through years of experience now is knowing how much you have to cut out, okay? Because if you do a standard test on the modules next to it, it could say that's absolutely fine, but it will have experienced more load and more heat because it's been near that failed cell and module. Therefore, have you started to get some form of fundamental chemical change? And normal testing doesn't identify that. So I know that when we've taken on programs from other people that have run with it, they've typically had a repeat failure rate of 30% within the first 3 to 6 months. We've never had a repeat failure because we can test and we can see actually that's okay now, but it's already started because it's been affected being next to something that's already failed. We know that that's going to then fail in 3 or 6 months' time. But that's taken us years to get that data set by having very close university links and sponsoring a lot of PhD work.
There was, Gregor, you had mentioned, I think for 2 or 3 wheelers, because the battery packs are smaller, there is the option of replacing the cell. Is that right? Is that how it's being done?
It depends on the battery you have. Like Mike said, he has some battery systems in which you can't replace individual cells. At our investigations, we had some where you could replace some cells and where you can disassembly to cell level pretty easy, but you at least have to undo the welding or something like that. But also a replacement of all cells would only be a quarter of a new battery system.
Do you see the market trending in that direction though, or does that result in an unwieldy expectation from a product design perspective? Sort of look at it at the cell level versus the module level.
I think it would be the next step to look at the cell level, but at the moment the manufacturing and the construction technology makes it pretty much impossible regarding safety and costs to switch individual cells.
There is more of a trend to go cell to pack. And what does that actually mean for us as remanufacturers? Well, if they do it in a way that these are small cells and it's just like one big welded modules and one big pack, that means that they're going to have to build in a lot of redundancy, because if they're going to have to assume that 1 or 2 of those, if they fail, are they going to really scrap an entire pack, or are they going to build extra redundancy? So they're going to make all packs have a little bit more capacity or circuitry within it that they could shut off and isolate a bit, but that means they have to make the packs much bigger in the first place. So it's physics. Nothing comes for free. There's a trade-off with what they're all trying to do within the designs. I'm just hoping if they go cell to pack as they seem to be to get that density, then that hopefully they'll use bigger cells with bigger welds that we can actually get in there. And yes, it will destroy that cell, but maybe we can replace a buzz bar and re-weld onto the good cells afterwards.
Got it. Perfect. Thank you. Just zooming out a little bit, looking at what's happening within the markets. As Jan mentioned, and there's a bunch of literature out there, the number of vehicles that are entering the market has grown dramatically and continues to grow. Where are we in the cycle of churn, which is to say, and the questioner has asked, when do you expect demand of remanufactured battery electric vehicles and cores in the market? So where are we in terms of, electric vehicles that were brought in the market a few years ago? Are they now the source of cores, and what's the expectation or trend in terms of that kind of cycle becoming a normal part of the market and industry mechanism?
So if I look at Mike, I think there is also already a demand.
Yeah.
Otherwise he wouldn't do his business.
The demand is coming at us a lot faster than we thought, and we're increasing capacity all of the time. As we put new capacity in it, we fill it. So the demand is definitely there. We're getting demand, two types of demand. One is from those early vehicles, which have now got 7-8 years on them. So they've got 1, 2, 3,000 cycles in some of these vehicles, particularly if they've been used for taxis. Is a great one for us because there's a lot of very high mileage early EVs, BEVs for those applications. So that's one part of it. But then you do have, now that the volume has picked up and you've got so many vehicles, new vehicles, it only takes a fraction of 1% of new vehicles to have a problem. And then you've got a manufacturer warranty issue. So we've got that aftermarket piece, mileage accumulation, and then we've got that warranty piece. And there's two different markets, two different customer bases for us. But cores are available. In fact, it's worrying the number of cores that are available because vehicles are getting scrapped when they're in so electric vehicles. If they're in an accident, all too often the insurance company doesn't know the state of health of that battery pack, and they're scrapping them off. And that means those cores come to market, and there's quite a large amount of people then buying those cores. And today, not necessarily putting them back into vehicle, but that's where they're going into these second life applications.
And that being secondary storage, like stationary storage applications.
Yeah. So I don't have a problem getting hold of cores. In fact, there's more availability of electric vehicle battery cores than there are engine cores.
Oh wow. Okay. And what kind of yield rate do you see, depending on, if you're getting 100 cores in, are you able to remanufacture 80%, 90%?
Run rate from the last 12 months is 91% recovered.
91%. That's great. Perfect. Thank you. Okay, we have some more questions coming in. We talked a little bit about testing early on. A more sort of general question is, what are the most successful, efficient ways to test, and how long do these processes take? I'm guessing the testing is in relation to testing after remanufacture. The questioner doesn't specify, but I'm guessing that's what was meant. Anyone?
We have quite an advanced test at the start, and then because you've already tested it and you've only replaced a certain amount of it, you don't necessarily need to do a full test at the end. But testing is certainly the most important part of the process, and can be time consuming depending on how you test it.
Got it. Thank you. Let's see. We covered Mike, you touched on warranty a little bit when you had the Tesla data on. Just to touch on it quickly again, and I'm guessing again this is a variable answer, but the question is essentially what's the warranty term of batteries of EVs from the car makers? So what's the coverage period, and when does it arrive in the remanufacturing ecosystem to give it a new life? So I think we touched on that a little bit, but Mike, if you want to quickly run through it. I mean, essentially you said 600, 300 to 600 cycles is
well,
where
that was an example on that there.
Yeah.
That's not my data. That you can Google and find that. If you look at Tesla data and just Google Tesla degradation, go down Google, you'll eventually find that graph.
Okay.
You've got in warranty now, which is these are very reliable. It's only small fractions of percentages that are failing, but that will increase as those cycles increase over time.
Okay. Jan, Gregor, anything you'd like to add there, either in terms of testing or the life cycle of EVs? Yeah, go ahead.
If you look at the warranty, often it's like 8 years or 150,000 kilometers for a state of health of 80%. But the question is also what happens after this warranty period. And I think that's more interesting to look at the aftermarket and also the potential for the recovery strategies, repair, remanufacturing of the battery systems, but also of the other components of electric vehicle, like the thermal management, the electric motors, and so on. I think there are different components besides the battery systems in an electric vehicle, which will be a great opportunity for remanufacturers in the future.
Yeah, no, thank you for bringing that up. And there's a question that came in that takes us in that direction. Before we get to that, just quickly want to ask, in terms of the market for remanufactured batteries, are they going back to OEMs? In other words, who are remanufactured batteries being sold to? Are they going to as an aftermarket product, or do they go back and become the battery pack for a new vehicle, or both?
It's ours at the moment is warranty replacement or customer replacement.
Okay.
So not into a brand new vehicle. It'll, if you've got a vehicle that's 6 months or 6 years old and it's in warranty, we're doing that on behalf of the battery manufacturers, the vehicle manufacturers, whoever holds that warranty liability.
Okay. Is there, or we don't know, I guess is the answer, are remanufactured packs ending up in new vehicles as well? Or is that
Don't believe
really
so.
Okay.
I think the OEMs won't do that to build in remanufactured products in the new cars. I think they don't do it at the moment for other Reman products. They would have to declare it, to mention it, and at the moment they are reluctant to do so, to emphasis on using remanufactured components within sales of new cars.
I do believe in one of the previous webinars, I think it was the one that we did focusing on the industry in China, there was, as a result of the supply chain issues that came into being because of COVID, I think there were some instances where remanufactured products were actually being introduced into new vehicles. If I remember correctly, don't quote me on that. I might have to go back and look at that webinar to know exactly what was said. But I think there is kind of that space where it's possible. But you're absolutely right, Jan. I think there is a more conservative approach that the OEMs are probably taking in that space.
I also think they can sell more cars than we've really got capacity to build battery packs. Most of them, okay? Not every model, but most are constrained by semiconductors, which we're getting better on. That supply is getting better, but then also battery packs. So when you think of a manufacturer, if you're in that warranty period, you've got a vehicle that's failed, and you've got a lack of battery packs, you don't want to be putting all of your new battery packs into vehicles that are already out there on the road, because that's going to stop you building as many new vehicles as you can. And that's why this in-warranty replacement for vehicle manufacturers is so important, because then they're just having to put 1 or 2 modules in out of the allowance and the overall capacity that they've bought. They're using it far more effectively, focusing all of that new, all of the new packs, other than a few modules, therefore, to give to me, for example, to use on their behalf. They're putting all of that into and maximizing the new vehicle sales, which in turn is making the whole transition to net zero happen faster. So right. we as remanufacturers are absolutely vitally important to it.
Mm-hmm. Great, no, thank you. So just a quick time check. We've got about 14 minutes to go. This actually is a really good segue into what you were mentioning, Jan, in terms of looking at more than the battery and looking at motors, etc. And the question is there a greater market for remanufacturing batteries compared to remanufacturing electric motors, or are they similar?
Too early to tell, I think. I don't think the market's mature enough. I'm surprised how many motor drives are failing. The engineer was trying to explain it to me on Friday from one of my customers, actually saying that it's the torque demand and the application really very, very aggressive on these units. We've got one significant program at the moment on rear drive motors, but we've got inquiries for quite a lot of others, and it's the demand for that seems to be higher. And in the last webinar, I said power electronics as well seems to be much higher, but unfortunately most of these power electronics have this potting that you can't get to the components. So being able to do full remanufacture of power electronics, I think, will be difficult. But these are all elements of these new vehicles, which are all new technology in many ways, but we're getting to market as an automotive industry as fast as we possibly can, and not necessarily thinking about what the sustainable angle is on these and how sustainable we can make them, unfortunately.
And I also think it's specific of the manufacturer and also the product. So
correct.
I think there's some
and application.
Yes, and
exceptions and applications. Yeah.
So sometimes there are possibilities to remanufacture also power electronics, but not in this great amount you would wish of.
I think at the end of our previous webinar, Fernand had mentioned, looking at the broader ecosystem, which is to say, from the standpoint of the vehicle, you still have components like the steering column, etc. So those are still fair game from a remanufacturing perspective, I'd imagine. Any thoughts on what that market looks like, or is that essentially just sort of filtering into what the existing market architecture already is for those kinds of components?
I'm not particularly engines and batteries is where my focus, and drive motors. I'm not aware of that market well enough to comment, really. I would imagine it will continue, and if you've got power steering on a motor drive on an ICE car, it's going to be the same on an electric vehicle. So I think what Fernand said was fundamentally correct. I mean, he's a really experienced guy. He doesn't get things wrong, does he?
But yeah, absolutely. And I think that's going to be important to remember, right? While I think batteries get a lot of the attention, not just from a remanufacturing perspective, but largely in terms of electric mobility, there is the overall architecture of the vehicle, which is made up of various moving parts, which are all fair game for remanufacture. And I think should be and probably are already being considered by OEMs for that. Great.
Yes, as mentioned in the last webinar, I think there are some new products which we are talking about, like the batteries, some with a bit transformation to have new application like brakes to get the energy back from braking to fill up the battery. And then of course there are also some components like the fuel injection, the combustion engine, which will be less important during the next years. I think this will should take some more time. It's not like they are vanishing from one year to the other, but I think in the long term they will fade out if there are only electric vehicles sold on the market.
Right. Okay, got a couple more questions coming in. This is more about the architecture of the market. Who usually receives the remanufactured batteries once the process is complete? Is it straight back to the manufacturers or a third-party company? So this goes back to what you mentioned, Mike, where it's essentially part of the warranty replacement. So I'm guessing it's essentially going back to the OEM, and there's no third-party intermediary in the space other than the remanufacturing.
We collect from dealers. We deliver back to dealers. We collect from factories, warehouses. Sometimes we have no logistics involvement at all. Really depends on the customer and the market and finding what the optimum solution is.
Okay, and in this particular case, the ownership stays with whoever at the time holds the battery, right? In other words, it's not a subscription-based model where the battery is still owned by the OEM, as opposed to the car owner owns the battery, and then once it goes to remanufacturer, it's owned by the remanufacturer for that period of time and then sold back to the dealer. Is that how it works?
It works exactly the same as an engine at the moment. Subscription models will come. Yeah, I've no doubt about that. But I'm not seeing it. I'm not involved with any at the moment, but I think they will come.
Great. Okay. There's a question. Is there a reduced driving range on remanufactured batteries compared to new production? I think the short answer to that is no, but Mike or anybody else want to elaborate?
You'll get remanufactured battery back to where it should be in theory after those number of cycles. So if it's dropped and it's dropped because of a module and you replace that module, it'll get it back up to where it should be on that chart that I was showing earlier, which is never 100%, but it would never be 100% anyway, because that battery has had some use. And that's where we as remanufacturers just need to be clear with everybody. If it's a remanufactured engine transmission, you're getting exactly the same durability and performance on it as you would a brand new engine or transmission. With a battery, you're putting it back to its maximum as it would be for that many cycles and time that it's had, but not completely new. As you saw on the data I showed earlier, you're up in the high 90%. So you're talking 95, 96%. You're not talking about only getting it to 70 or only 80. Typically at 80, that's a fail, and you're trying to get it from 80 back up to 95 plus.
Got it. Okay, I stand corrected.
It's very technical.
Yeah. No, thank you. That's helpful. That's kind of why this Q&A session made so much sense. So we've got just a few more minutes left. I want to come to each of you, maybe just in terms of trends, where we're headed, over the next few years, in your own words, specific either to technology or markets. If you could think about and share a little bit, what to expect and what maybe areas of research you're seeing coming through, and where you see the industry going in just a few words. That would be a good place to bring us to a close for now. Jan, do you want to go first?
Yes, I can start. So I think from a researcher's perspective, it will come up with the disassembly on cell level, to also have the opportunity to just replace the single battery cell which failed within a module, and do it in a not that time-consuming way. So that is also from an economic perspective viable. And I think that in general, that the possibilities to remanufacture battery systems will become more and more efficient through the next years. And I think there will also be some more legal requirements beside the economic consideration. So to repair, to remanufacture the battery systems instead of just recycling them. And maybe I can also add something to this point. So at the moment, the material recycling gets promoted from the recycling industry, for example. But you have to keep in mind that in most cases, you can't just produce or manufacture a new battery cell from this material, which comes out as a result of the recycling process. So I think there are also some ways to go to have the materials which end up in this grade to use it also in the production of new battery cells.
Great, thank you, Jan.
Okay, for my opinion, I think the electronic mobility will grow stronger. We will get new technologies, higher energy densities, with that more range in our cars. The infrastructure and the charging cycles or the charging time will get better. And with the remanufacturing aspect and the recycling, the battery systems will also get cheaper. And so all the risks and dangers of acquiring an electric car will lower, and so more people will switch to electric cars just because they are more eco-friendly. You can get more power, and with the technology arising, it will just overpass the internal combustion engines at some point.
Thanks, Gregor.
Both Jan and Gregor, absolutely spot on, correct as usual. Thank you. Just picking up what Jan said there, what we do need to do is promote remanufacturing compared with recycling. There's some data which I'm going to get on the Autocraft website in the next few months, which shows that compared to making a new pack, recycling, you are still only benefiting by about 30% of your energy, your water, your CO2. So recycling isn't that green compared with Autocraft at the moment. We're down at just about 5 or 6% of the same amount versus making a new pack. So we are over 90, 95% greener to remanufacture compared with new, and over 60% greener than doing the recycling. And we've got to stop politicians and the industry moving towards recycling as the solution, because it is not green enough.
No, that's perfect, and thank you. There were a couple of questions on legislation that we didn't get to. There's a couple of links that I have shared with Kim. She's going to pop them into the chat. One of them is about the new EU rules for more sustainable and ethical batteries, as well as a really great article that was published by Nature magazine earlier this year on the circularity of the whole ecosystem in relation to EVs. So I'm giving whoever is here a little bit of homework reading if it's of interest. But thank you for joining us. Please don't leave just yet. Kim has a quick announcement for us on Rematec 2023 that's coming up next year. As you know, as you're well aware, these webinars are being hosted by Rematec, and they've got they do such a great job in hosting the world's largest remanufacturing industry expo in Amsterdam, as well as Rematec Asia in China. So I'd encourage you to hold on for just a couple of minutes here as Kim plays that.